In this video, we are looking at conditional probability, about understanding what that means if they're conditional, how to calculate conditional probability using a number of different methods, and using the formula for conditional probability. So let's start off with a definition for the conditional probability. It's one of those ones, once again, that in words can seem a little bit confusing, but with examples and diagrams becomes a bit clearer. So the probability that B will happen if A has happened is the conditional probability of B given A. So we're assuming that A has already happened, given A is assumed definitely happened. If A has definitely happened, how likely is B going to happen? So this notation here is B given A. This line always represents the word given. So A has definitely happened. How likely is B to happen? So let's say we've got a character called John, and John sometimes takes his coat to school and sometimes doesn't. Now, he's more likely to take his coat to school if it's raining, which seems very bizarre because if it's raining I feel like he should definitely take his coat, but in this problem he doesn't. If it's raining, the probability he takes his coat is 0.9. So pretty sure, but not always. And if it's not raining, then the probability he takes his coat is 0.2. Okay, now we're going to look at this in terms of conditional probabilities. Okay, now these are unnecessarily long at the moment. We can easily use symbols for this instead. So let's use C for coat and R for raining. Okay, so this we could easily write as the probability that he takes his coat, and given that we write like this, it's raining, and that probability is 0.9, just this one. And likewise, probability that he takes his coat, given that it's not raining, is 0.2. And that's just what that definition is, what that notation is, and how we write it out. Okay. We're now going to look at a worked example which includes practice of drawing tree diagrams. Okay, this is rather a long question, but we'll look at each part as it comes. A delivery from a subcontractor contains 9 similar components. 4 of the components are faulty. Not great, probability there already. A component is chosen at random, checked for faults and not replaced. A second component is then chosen and checked for faults. Now, if it's checked for faults and it's faulty, then obviously that's not an acceptable component. Okay, part A, work out probability that the second component is accepted given that the first is accepted. Part A, I. So at the beginning, we had 4 faulty and 9 in total, so we must have had 5 acceptable. Now, if given that the first is accepted and not replaced, so there were 5 accepted, there's only 4 accepted left, still 4 faulty. So for the second component to also be accepted would be 4/8, which you could obviously also write as 1/2. Likewise, we know that the first is faulty for the next one, so we had 5 and 4. We've now only got 3 faulty left and still 5 acceptable, so for us to have acceptable the second time, it's 5/8, which I cannot simplify. Now it's actually a lot more efficient to write this as a tree diagram because we can do everything at once. Unfortunately, part B, that is actually what we're being asked to do. So let's have a go at that. So we're going to draw a tree diagram, and each component is either acceptable or faulty for the first one, and acceptable or faulty for the second one. Now the probability the first one is acceptable is 5 components out of 9, or faulty is 4 out of 9. Now remember, we're not replacing them, so we only have 4 and 8 here, 4 and 8. If the first one's faulty, there are 5 left acceptable, or 3 left, faulty. So those are my probabilities, but it also wants all possible outcomes. So the probability of acceptable is 5/9 times 4/8, 20/72, and let's do that for all of them. If you pause it now and fill in your sheet and then check in to see if you were correct. You can write simplified versions if you wish, you don't need to, but you've got your calculator, so if you put any of them into your calculator, it will give you the most simplified version anyway. Okay, so we've done part B, and we now just need to use this information for part C. So what's the probability of 2 acceptable components being selected? Well, that's got to be acceptable. Probability of acceptable is 20 out of 72, which you might have as 5/18. Okay. Probability that the 2 components are both accepted or both rejected. So you've got accepted, and rejected. So you need to add your 20/72 and your 12/72 to get 32/72, which you could simplify down to 4/9 if you wish. And the last one, at least one component being accepted. Well, you could do this a couple of ways. You could either add together both accepted and all the 1 accepteds, and that will give you the total. Or if at least one is being accepted, then the only thing you can't have is both being rejected. So you could do 1 take away this. And let's look at both and show that we will in fact get the same. So 20 plus 20 plus 20, all out of 72, will give us 60 out of 72. Or if we're looking at this method, 1 minus 12 out of 72 will also give us 60 out of 72. So either way, that should be our final answer, which you could simplify down to 5/6. So you can choose the method, it doesn't specify. Okay, so that was a bit of practice on using tree diagrams and conditional probability, and we're also now going to look at using Venn diagrams, and with this it's very visual and you can just look at it. Okay, this Venn diagram shows information about the songs in Kaylee's music library, and we need to find a couple of probabilities. So first of all, if Kaylee plays an R&B song, what is the probability it is by a female artist? So what I'm looking at is given R&B, I know it's R&B, so I can write it like this. If I just have female as F and R as R&B, then this is the probability that it's female given that it's R&B. Okay, well I can see the R&B ones. The total of R&B is whatever 350 plus 525 is, and the female part of it is just this part, so that's just 525. And if I sort that all out, I get it simplified down to 3/5. That's all there is to it. So look at B now. If Kaylee plays a song that is not by a female artist, what is the probability it is R&B? Okay, so it's not by a female artist. So if this is my female artist, I want everything that is not by a female artist there. And the way I can write this is the probability is R&B given that it's not a female artist. So the total number of not female artists are this 350 and this 175. And out of those, the 350 are the R&B. And if I simplify that down, that gives me 2/3. Okay. We're now going to move on to the formula of conditional probability of B given A. Okay, so this probability, the probability of B given A, is the probability of B, or A and B, all divided by the probability of A. And this can be rearranged to a useful result, which is this. The probability of A and B is equal to the probability of B given A multiplied by the probability of A. So make sure you've got those written down. and there'll be another formula that will come along in a minute. Worked example. At a doctor's surgery, 5% of all appointments are for elderly patients with high blood pressure. 1/5 of all appointments at the surgery are for patients with high blood pressure. An appointment is made for a patient with high blood pressure. What is the probability that the patient is elderly? Okay, so let's have H be high blood pressure and E be elderly. So we know the probability of high blood pressure is 1/5, which is also 0.2. Okay, we also know that the probability of elderly with high blood pressure, and high blood pressure, is 5%, which is 0.05. And we're asked to find the probability that they're elderly, but we know that they've got high blood pressure, so given that, they've got high blood pressure. So if we use our formula, this is the probability of E and H all divided by the probability of H. So we've got 0.05 divided by 0.2, which is 1/4, 0.25. So the probability that this particular patient is elderly is 1/4, or 0.25. So you need to be able to use this formula and practice using that. And you'll have a go at practicing that in a minute with some practice questions. You've just got one final formula to write down. We already know that if two events are independent, then the probability of both events happening you can get by multiplying them together. But there's another rule around independence, and that is this. And you can use this to test if they're independent, because if these two things are equal, then they are, and if they're not, then they're not independent, so they're conditional. Okay, have a go at the practice questions now.